Okay, so in this video, I'm creating a little video about the 2021 Section A in the higher level paper, and I'm looking at question A3. This question is based on the hedral angle and the tetrahedron. Now, part A and B, very straightforward, very standard dihedral angle or tetrahedron or true angle questions. We've been asked to determine the dihedral angle between ABC and ABD. Just like with normal dihedral angle, first establish the line of intersection between ABC and ABD in plan. You can do it in elevation also, but we were used to working with plan. That is the line AB. So I'm going to call that 1, 2. We're going to find the true length of 1, 2, and we're going to find 1 point off of the surface ABC, so we'll use C, and we're going to take 1 point from the surface ABD, so we'll say D. So using my set squares, I'm going to get the true length of the line 1, 2. So I have 1 and 2. And at the same time, I bring out D and C, which you'll see in this particular case are on the one line. And I construct an XY line just out to one side. Elevation XY plan, XY elevation. So this is a plan crossing a new XY going into a new elevation. The heights of 1, 2, D and C in front elevation will be the same heights of 1, 2, D and C in this new elevation. D and C have 0 heights. So there is D and C. They're on the X1, Y1 in this. Point 1 does have a height. It's the altitude of A. So there is point 1 found. It's the altitude of the tetrahedron. That's point 1. And point 2, which is B, has a 0 height also. So it is located here. We then look along the true length of 1, 2. So this is the true length of 1, 2. We're now going to look along that true length. So using my set squares, I look along the line to 1. And I also bring D and C at the exact same angle. And again, 90 degrees to those two lines. I construct my next XY. Now, so this is a new elevation. This was its plan. New elevation, crossing XY, we're now going into a new plan. Therefore, the distance from the X1, Y1 into plan will be the distance from the X2, Y2 into plan. So that is the location of D. So this little small distance here is this little distance here for D. From this X1, Y1 to C will be this X1, Y1 to C. There is C. And you'll notice that 1 and 2 are equidistant, same distance in this particular view, because the line 1, 2 has become a dot. Because you're looking along a true length, naturally that line becomes a dot. Joining that up finds for you the required dihedral angle in the tetrahedron. You should measure that with a protractor and write down what that angle is. Always when asked the dihedral angle, give what it is in degrees. You then asked me to determine the true angles between the line BN and CN. Now, N has a different altitude. BN and CN. Here is CN, here is BN. We're asked to find what is the true angle between them. And the best way to go about that is to basically get the true shape of the triangle ABNC. We already have a true length for BC. So I am going to go perpendicular or continue this line from AN on out. And what I need is the true edge length of the tetrahedron because the line, what I need now is the true length of the line NB. And we don't have a true length for NB at this particular moment, but we can use some of our information here to find that true length for NB. We can basically use this auxiliary plan here. If I take the height for N and map it onto here, That's where n is. It's on the same line as a and 1, as I've labelled coming on out. And joining 2 to n, which is the same as joining b to n, that particular line there is the true length of the line bn, which is also the true length of the line cn. Taking that length of my compass, swinging that from C or B, completes the question. You'll see all 3 points cross over at the one place. So the required angle that you're looking for is here, and we'll call that angle there pi. Measure the angle pi for the true angle that's required at part B. Okay, thanks very much.